Hi, my name is Daniela Lopez. I'm in calculus class, third hour, and this is my presentation on the chapter 2 of related rates. So this is our problem. A 13-feet ladder is falling down a wall at a rate of 1/2 feet per second. How quickly is the angle between the ladder base and the floor changing when the distance from the top of the ladder to the floor is 5 feet? So we're going to start by drawing two triangles. And in the first one, we're going to set up our variables. So we're going to start by calling this h, which is going to be our height. Then this is going to be b, which is going to stand up for base. And this is going to be l, which is going to stand up for length. From the information that they give us on our problem, we know that h is equal to 5 because it says here that the distance from the top of the ladder to the floor is 5 feet. Then we also know that the length is equal to 13 because we know that the ladder is 13 feet. So now we're going to use our Pythagorean theorem so that we can find our value that we're missing. And we know that L squared is equal to 13 squared, and then h squared will be 5 squared plus b squared. So then we have 169 equals 25 plus b squared, and then we're going to subtract 25 from both sides, so we get 144 equals b squared, and then we take the square root of both sides, and then we get that 12 is equal to b. So now we have the 12, and we also have the data, which is going to be the value that we're trying to find because we're trying to find the angle. So we're going to have to set up an equation. So in this case, we're going to use sine of theta because we have all these values, which is h and l. So now we have to take the derivative of this equation. So we know that the derivative of sine of theta is cosine of theta. And the derivative of theta is going to be theta prime, so we're going to pull that theta prime to the front. And then it's going to be equal to h prime over L, and then we just take the derivative of h prime because we know that L is a constant because L is not changing, because we know that the ladder is 13 feet, and we know that those 13 feet are not going to change because the ladder is going to stay the same. It's not going to get bigger, it's not going to get smaller. So now we have to substitute into this equation. So we have theta prime equals cosine of theta. So we know that cosine of theta is adjacent over hypotenuse. So we have cosine of theta, which is adjacent, which is going to be 12 over hypotenuse, which is going to be 13, equals h prime. So we know that h prime is 1/2 feet per second because that's the rate at which the ladder is falling. So 1/2 over L, which is 13. So now what we're going to do is we're going to multiply both sides by their reciprocal, which is going to be 13 over 12. So if we do that, these two terms are going to cancel. So we will just get theta prime on this side. And then from this side, we can divide by 13. So then we will end up getting 1 over 2. And then that 13 is going to become 1. So we will actually have 1/2 times 1 over 12. So we are going to get that theta prime equals 1 over 24 radians per second. And that is going to be our answer. So we know that the angle between the ladder and base and the floor is changing at a rate of 1 over 24 radians per second.